So now I want to show you some actual functions from the Berlin core to give you an example of what the syntax looks like with slightly more complex examples than the ones I've given you. In this case, we are looking at the syntax of the map function. Now what map does is I described it and I explained it in the previous video. Map basically takes a function and a collection, and then it applies the function to each item in the collection iteratively, and then returns a new array with the results of all those operations. So for example, if you have an array 1, 2, 3, and you have the function inc for increment, then your new array will be 2, 3, 4 because it increments each number. So how might you implement this? There are different ways you could implement the map function. In this particular case, in Berlin, the map function is implemented recursively and without mutation. The first thing we do here is we declare a variable called map, and then we assign a function to it. That's the step right here. Don't worry so much about all these closing parentheses here. They may stand out to you at first, but don't worry about them. Sooner or later, you won't even see them anymore. Okay, now this function takes two arguments. I mean, three technically, but it takes two arguments, f, the function f, and a collection call. And I say three technically because if you look at this function body, we're still within the orange parentheses here. So technically this is the third argument because again, if the function's body is also just one of its arguments. Now, because of that, you could in principle, if you wanted to make it more clear that this is the function's body, you could wrap these in a block in parentheses, and curly braces, I should say. But because there's only one statement in this block, you don't need to do that. Now, you may be wondering why I'm saying that there's only one statement in this block, because it looks like there's 4 statements, right? I mean, we have 4 lines of code. But actually, there's only one statement in the sense that there is an if statement, and then everything else that happens nested within the if statement. So as far as this function is concerned, there's only one thing happening, and that's if. And then everything else that happens, that's up to if. The function doesn't have to care about that. The only time you would really need the curly braces is if you wanted to do something else here. But you won't really find this case that much. Sometimes maybe if you do mutation or something, or you just needed to log something here, and then you go about your business here. That's maybe when you would do something like this where you have multiple elements that are siblings that are on the same level. But otherwise, because nothing is mutated and everything kind of carries the results over from the previous call, lines tend to get nested like this. I mean, you don't have access to anything that cons did here. So you would really go on and do a completely separate operation here. But in any case, like I said, this won't happen often. So you don't really need the curly braces that much unless you deal with sets and maps. Okay, so what is it we do in the function body? Well, first we check if the collection is empty, because if it is empty, we don't really have anything to do. And then we might as well just return that collection or an empty array. It doesn't matter. Okay, and if it's not empty, that means there's at least one item in the collection, and so we have to keep going. We still have stuff to do, basically. We're implicitly using the remaining items in the collection as a counter as to how many more times we have to recur. So the first thing we do then is we declare a variable called L for element, and we set it to the first element in the collection. And then what we do with it is we construct a new array that will have as its first element the result of invoking the function we were given with this element. So that's what we do here. That will be the first element of this newly constructed array. And all the other elements will be the result of calling map again, we're recurring here, with the same function and the rest of the collection. And eventually, the rest of the collection is going to be an empty array, and that's when it loops back up here, at which point it'll check, is this empty? And then it'll just return an empty array. And if we construct something with an empty array, we're simply putting something in an empty array. So this doesn't result in nested arrays. That's something that misled me initially. This is still just an even non-nested array, so to speak. And I find this approach very elegant because, and this approach isn't new, this has been used in other languages a lot, this kind of recursive, non-mutative approach. I find it elegant because when you use recursion like this, it's almost like you don't really ever have to care what the map function really does because you just keep delegating. You just keep saying, just construct a new list with this element and whatever the map function returns. So in any case, I hope this gives you an example. This gives you some insight into what a real life solution to a problem, what the syntax for that solution would look like in Berlin.